Alright, today we're going to be starting our new unit. This is graphing nonlinear functions, so functions that aren't lines, and we're going to start with absolute value. Hopefully you remember from the beginning that absolute value graphs look like these. So we're going to look at our parent function of an absolute value. Before we do that, I want to focus on the parent function, the linear, something to relate back to. Okay, if you recall, there are two important things. One was the slope, and one was the y-intercept. Okay, the slope of the parent function was 1 over 1, and the y-intercept was 0, 0. So we went 0, 0, and then we went up 1 over 1, up 1 forward 1, and then we went down 1 backwards 1, and you had a nice line. Okay, that was the parent function of a line. Now let's look at the parent function of an absolute value graph. To do that, we're going to start with a table. I'm going to plug in x's, and then we're going to find y values. So first we'll start with 0. If I plug in 0, the absolute value of 0 is 0. If I plug in 1, the absolute value of 1 is just 1. If I plug in 2, the absolute value is 2. Plug in 3, 3. Remember, absolute value just makes the number positive. Well, if I plug in a negative 1, the absolute value of negative 1 is a positive 1. The absolute value of a negative 2 is a positive 2. The absolute value of a negative 3 is a positive 3, and so on. So you can see that it's going to continue in this pattern going this way. So what you need to remember are the key parts of an absolute value parent function. There's two things. One is the slope, just like in a line, only there are two slopes. The slope of this is down 1, forward 1, whereas this side is up 1, forward 1. So you can see that it has two slopes. It has a negative 1 and a 1, positive 1. But the other important piece is the new thing called the vertex. The vertex is the corner of the V, that sharp point. Okay, this is your vertex right here. And that point is the point 0, 0. So now you need to know that the vertex of an absolute value graph starts at 0, 0, and then it goes up 1 and it goes down 1. Those are the two things you need to remember. You will need to remember this for the rest of the unit, not just today. So let's look at some graphs. And again, I like to relate it back to something we already know, linears. What does this thing change? When you add a number to the end of a linear graph, what does it do? Well, our parent function went through 0, 0. That was our parent function. But if I'm interested in this guy, this changed the y-intercept. It moved the y-intercept from 0 up to 3. But it did not change the steepness, so it's still up 1 over 1. Down 1, backwards 1. So if you can remember, when you add a number to the end of the equation, it shifted or moved the graph up 3. I was at 0, 0, and now I'm at up 1, up 2, and up 3. Up 1, 2, and 3. Alright, now I'm going to do that same thing. It actually works out to be the exact same thing in absolute value. If I add a number at the end, I am going to move it up or down. So in this case, because it's a plus 3, okay, because it's a plus 3 at the end, I am shifting the graph up 3. So what I'm shifting is the vertex this time. The vertex of the parent function, again, the vertex of the parent function did look like this. It was at 0, 0. So if it was at 0, 0, my new one is going to be shifted up 3. So 1, 2, 3. Here's where my new vertex is. And I go up 1 over 1, up 1 over 1, up 1 to the left 1, up 1 to the left 1. And I have my new absolute value graph. So it's important that you remember where the parent function is, right here. so that you can know that shifting it up 3 moves the vertex up 3 spots. All right, so now let's look at the next equation, this one here. We know the parent function's vertex is right there, but this -4 on the outside means I need to shift down 4. So instead of being a 0 to 0, I'm going to go down 4. 1, 2, 3, 4. That's my new vertex, and then my slope is still up 1 over 1. So there's 1/2. And then backwards 1. So I get the V shape. You're always going to have a V shape when you have an absolute value. It's just the way it works. There you go. So I haven't changed the steepness, the slope is the same, but I am shifting up or down, depending on what I'm adding or subtracting. So if we want to summarize our rules here, here's what you need to remember. The parent function. The parent function is y equals the absolute value of x. Nothing else. No numbers, nothing else. And there's 2 important pieces. You need to remember the rate of change is -1 and +1. And you need to remember the vertex is 0, 0. The next thing you need to remember is that when we add a number to the end, okay, when we add a number to the outside of the bars. Okay, so let me give you an example. Y equals the absolute value of x. We're going to give it some letter. It could be any number, right? It could be a +5, could be a -6 or whatever. We're going to call it a k, just because it's typically what mathematicians do. They'll call this number the k value. Okay? When we add a number to the outside of the bars, it shifts. That's the key word. Shifts up or down. Okay, and I'm going to come back here and say add or subtract. When we add or subtract a number to the outside of the bars, it shifts up or down. You absolutely have to memorize this. Okay, you can always make a table, but eventually this needs to become second nature to you, and you need to commit this to memory. Because it's different if I add or subtract a number inside the absolute value bars. Before I do that, I have 2 problems that I want you to do. Go ahead and try graphing them if you can. If you get stuck, feel free to pause the video, try to do it yourself. If you get stuck, unpause it and see how you did. Then try the next problem. If you get stuck, unpause it and go from there. All right. Hopefully what you notice on this one is this is a linear equation. It's not an absolute value, so it's not a v. It's just a straight line. The slope is 1, but we had to move down 4. So I started here. I went down to -4 for my y-intercept, and then up 1, forward 1, and kept it as a straight line. Pay attention to what kind of equation it is. Now go ahead and try this absolute value equation, see how you do, and then pause the video before you try it. All right, so this one, still the rate of change is -1 and +1. Because I'm adding a number on the outside, I'm shifting up 1. That's describing the transformation. I shifted up 1. That means my vertex is now at 0, 1. So here's my vertex, and I go up 1, forward 1, up 1, forward 1, up 1, forward 1, and then I do the V going the other direction. Now, what do you notice about these equations? These equations, the number I'm adding or subtracting, are on the inside of the bars, where we just did one with the number on the outside. So as we focus on the numbers on the inside, I'm going to make a table for the first time. You do not have to make tables every time because we're going to learn the rules, so we don't have to make tables. If I make a table for this guy right here, I'm going to plug in -4. If I plug in -4, we'll start with -5. We'll go all the way to the back. -5. -5 plus 3 is -2. The absolute value of -2 is 2. Let's go to -3. -3 plus 3 is 0. Absolute value of 0 is 0. Let's go to -1. -1 plus 3 is 2. Absolute value is 2. We'll go 1. 1 plus 3 is 4. Absolute value of 4 is 4. Let's see if we can graph that. -5, 2. 0, -3. Or sorry, -3, 0. -1, 2. 1, 4. You can actually see the V shape. Okay, so I made a table. You're always welcome to make tables, but eventually you want to learn all the rules. Where's the vertex here? The vertex is at -3, 0. The vertex is usually at 0, 0. So what happened? It shifted to the left. 3. So if here I looked at it, I had to add 3, but I shifted to the left. Let's look at this guy. Again, I'm going to make a table. Eventually you will not make tables, you will memorize the rules, but tables are always a good fallback. Okay? Let's plug in 0. 0 minus 4 is -4. The absolute value of -4 is 4. Let's plug in 1. 1 minus 4 is -3. Absolute value of -3 is 3. Plug in 2. 2 minus 4 is -2. Absolute value is 2. 3 minus 4 is -1. Absolute value of that is 1. 4 minus 4 is 0. Absolute value of that's pretty simple. 5 minus 4 is 1. Absolute value of that is 1. Notice that my table just repeated, so I'm going to go ahead and graph the rest of it. I got 0, 4. It's here. 1, 3. 2, 2. 3, 1. 4, 0. 5, 1. See the V shape? Okay. It's the same looking V shape. Down 1, forward 1, down 1, forward 1, up 1, forward 1. Same slope, same V. The difference is where the vertex is. Now my vertex is at 4, 0. Well, the vertex is usually here. This time it moved to the right. So we would say shifted right, how much? 4. Shifted right 4. So you can see now that when you add numbers in the inside, what it does, it shifts the graph either to the left or to the right. The key is it's kind of backwards of what you might initially think. When I subtract 4 on the inside, it goes to the right, but when I added 3, it went to the left. Those are rules that we have to memorize. Okay, so let's go ahead and write that down. We have our parent function. Okay, these are rules for horizontal shift. Our parent function is y equals the absolute value of x. Okay. Now, the new rule is if we add or subtract a number to the inside of the bars. Okay, so no longer to the outside of the bars, but to the inside of the bars. Then the graph shifts left or right. Okay, and I'm going to make this note. Add, it's kind of the backwards of what you think. Add goes to the left. Subtract goes to the right. A lot of times the way mathematicians will write it is y equals the absolute value of x minus h. So we're looking at that h value there. Let's do some practice problems. We're going to graph the two equations and describe the transformations. I'll do the first one and then I'll pause it and have you guys do the next one. This guy, notice that I'm subtracting on the inside. Well, if you go back and look at that rule that we just talked about, subtracting on the inside means I move to the right. So immediately, I'm going to say this graph is shifted right. How far? Well, right 1. So if my vertex was at 0, 0, now my vertex is here. My slope is still the same. So up 1 over 1. Then up 1, back 1. Make that V. And that's it. Shifted to the right. Go ahead and pause the video. Try this one. Give it a shot. And then unpause it and listen to the explanation to see if you got it right. Alright, here's the answer. What I noticed again is I was adding to the inside, and if I look at my rules, adding to the inside means I go to the left. So I went to the left 4, and then did my rate of change of up 1 over 1, up 1 over 1. So now let's try to put them both together. Notice that now I have number on the inside and on the outside. Well, what did adding on the inside mean? Then if you go back to that rule, look at your notes. Adding 2 on the inside means that we shift left 2. But the subtracting 3 on the outside, if you go back and look at the beginning, that means we shift down 3. So I'm going to start at my original, which was 0, 0. I'm going to shift left 2 and down 3. But that's all that's done, so my rate of change is going to be the same. Up 1 over 1, up 1 over 1, up 1, backwards 1. Make the V. So if I look at my vertex, because that's my important point right there, my vertex is at -2, -3. Now let's come to this guy. 2 numbers again. What does the number on the inside do? It moves it left or right. Because I'm subtracting 4, that means I shift to the right 4. Okay? What is adding 3 at the end? That means I shift up 3. So I start at 0, 0, go right 4, up 3. That's my new vertex. Now I have to make the rate of change. Up 1 over 1, up 1, backwards 1. It's a little v, but that's just because our graph is little. There you go. Now let's look at the vertex. The vertex, the most important point right there, that's at the point 4, 3. Couple more questions, just to application. Look at the 2 graphs. Can we describe the rate of change and then write a new equation based on that? Well, what's the most important point we've been looking at? The vertex. So there's the vertex. What did the vertex do? I went left 2. So if I describe it, I would say shifted left 2. Well, how do we go left? We have to add a number to the inside. So that would be y equals absolute value of x plus 2. That's your equation. Because if you add a number on the inside, you shift to the left. Come over here. Where's my vertex? So my vertex was at -2, 0. This vertex is at 3, -2. So what happened? It got shifted to the right 3. Well, how do I go to the right 3? Shifting to the right means that I have to subtract the number on the inside. But it also went down 2. How do you shift down 2? You subtract a number on the outside. So this equation matches this graph. All right, that is it. Go back and study and memorize these rules about left and right and up and down, and you will be set for the next